Let's do another relative velocity problem. A plane directed due west with a velocity of 240 kilometers per hour relative to the air encounters a wind going 65 kilometers per hour at 35 degrees north of west. Before we even finish the problem, let's write a few things down. The velocity of the plane relative to the air is 240 kilometers per hour west. Encounters a wind, that's air, going 65 kilometers. All right, so the velocity of the air relative to the Earth is 65 kilometers per hour at 35 degrees north of west. And what we want is we want the velocity of the plane relative to the Earth. In terms of the variables, what do we have to do? The first variable here has to be a p. So I got to go velocity of the plane relative to, well, the only thing I got is the air. Got that. Now, the next vector, without even looking, that has to be an a, because birds of a feather flock together. The velocity of the air with respect to, well, the only thing I got is the Earth. And let's see. Hey, look at that. We need to end with an E. We end with an E. There you go. That plus that. So no flipping. This vector as is. This vector as is. All right. Well, what would those look like? If we sketch them out, isn't this true? Usually north is that way towards the top of the paper. So 240 kilometers per hour west would look, kind of like that. And again, because of our equation down here in the lower left, we see that we don't need to flip any direction. We can just leave it the way it is. 65 kilometers per hour at 35 degrees to the north of west. Well, west is this way. So 35 degrees to the north would be kind of like that, maybe, where this angle right in here is 35 degrees. And that vector has a length of 65 kilometers per hour. And so the vector that we want is this one right there, that dashed line right there. That's the vector we want. And we're going to need an angle in our answer as well, aren't we? That one right there. The angle is always back at the beginning when you add vectors. Hopefully you've done this in earlier physics classes, because I'm not going to take too much time to do it, but I will explain what's going on. We need to then break this 65 kilometers per hour into a westerly component and a northerly component. And I did that already. I got that the westerly component is 53.24 kilometers per hour. I like to leave a few extra sig figs whenever I'm doing these, what I call intermediate calculations. 37.28 kilometers per hour. And then to add these vectors, 240 west plus 53.24 to the west, which gives us a total of 293.24. So basically what we have is we end up with 293.24 to the west, and then all by itself 37.28 to the north. And then we need to Pythagorize those and use the inverse tangent function on our calculator. I'm not going to go through that with you here. Hopefully you know how to do that, but you want to use the Pythagorean theorem on those. When you do, you get a number that is basically 300, and at this point we want to report proper significant figures. So the only way to report 300 with two significant figures is to write it like that. 3.0 times 10 to the second kilometers per hour. And then we also need, as we mentioned earlier, we need to find this angle using the inverse tangent function. And you can see it's a pretty small angle, definitely less than 35. I got 7.2 degrees. And then what is this? North of west. So maybe you want to check my calculations on that. But that's how we go.